Hi, this is Andrew. I'm just here to introduce the presentation from March's Meetup of Data Science South Coast and Solent IoT and AI. We've got a great presentation from Tom Wright, who's talking about the use of artificial intelligence in marketing automation.
I think one of the things that one of the interests that I had in joining this group initially is that data science and algorithms and all these different buzzwords have become prevalent in advertising, and that's my background is 10 years in specifically kind of online advertising. Which is now kind of being changed to, the words are kind of being changed to connected advertising now, because the difference in online and offline are being blurred. And all of this stems from the kind of the .com boom straight into online publishers, and then the data footprints that all of these publishers collect, and then how to then turn this data into an asset that can be used for better advertising, more relevant advertising, and advertising that can be used for businesses to target audiences online. So just a quick introduction to myself. I've co-founded a couple of businesses in the last 10 years using biddable platforms. So any advertising platform that is auction based is considered a biddable platform. So that's Google, Facebook, LinkedIn, Microsoft, and other big names that you may or may not have heard of, such as AppNexus. And I'm going to try and I understand there's various different understandings of in this meeting in particular of advertising, and especially of data science. So I'm going to, I'm sure there'll be some bits and pieces that don't make sense, but I'll do my best to try and explain. I've worked with clients such as Amazon, Greenpeace, Peach Express, and things like that, all running their biddable media for them. And the reason kind of biddable media is so prevalent at the moment is because the more people who are kind of advertising online, and the more publishers that are putting or publishing content on the web and in app, there needs to be a marketplace to facilitate the buying and selling of all of that inventory, and that is underpinned by data and data science. So traditionally, I use the analogy that kind of your old school advertising, your newspapers, your TV, your billboards are kind of a bit like analog, and then that all moved to digital, where you're on your websites, your banners, and video and things like that. But then the next quantum leap has been from digital to programmatic, which is programmable media. So where where all the data points that everybody leaves as they navigate the internet, the device they use, I'll list them later in the presentation, but everyone has a digital footprint, and it's all this data that is abundantly available online, but obviously with the privacy, Cambridge Analytica, scandal, all this, its privacy is a big thing at the moment. So the industry is evolving quicker than it can be regulated, and that's kind of that's why the importance of data and data science can help to it's the governing kind of the governing factor of online advertising now, because of the data that's available and that is left by people when they navigate the internet. So this is the Internet Advertising Bureau's definition of programmatic advertising. So simply stated, programmatic advertising is the automated process of buying and selling digital ad inventory, connecting advertisers to publishers to deliver ads to the right person at the right time in the right place. So obviously, for it to know where you are, what time is the right time to show you, and who the right person is, it needs data. I've added a little bit at the bottom there that I think should be extended. to using cookies, browser, and device data points to denote context, behavior, and demographical properties associated to each user. So everybody is everybody is identifiable online anonymously. There are data companies, Experian being one, where people voluntarily submit their demographical data there and are put into audience segments available to advertising platforms like Google and Facebook to target. Because of the submitted information. So, and I mentioned earlier about the auction-based system. This is also known as real-time bidding. So here's some, this is by no means an exhaustive list, but it's just an example of some programmatic publishers. In fact, any publisher who sells any form of advertising inventory online, will sell it programmatically. They will, which technically means that they will sell it by virtue of the data that surrounds it. So it used to be the day where you would approach Yahoo and say, hey, we want the homepage takeover for 30 days. It would cost, £250,000 for a month worth of tenancy, they'd call it, but you would be getting all of the audience. So even if it was a sports brand that wanted that kind of homepage takeover, you're not guaranteed that you're getting that audience, and you're not guaranteed that it's inefficient. So as data started to be collected in the form of cookies and organized, and people were able to be identified by their behaviors and interests, that's when publishers started to segment their audiences and make those segments available for targeting. I'll go into a bit about how that works. But here's some of the formats. So we've all seen display ads. You've got your leaderboards, your mid-placement units, which is the one here, and display is the oldest form of text links are technically the oldest form, but banners are they're a legacy type of ad, yet they're still the main currency of digital advertising in terms of efficiency. And so display ads, everyone's seen them. People use ad blockers, but there's different ways of getting past these things, which I'll go into in a second. But just to give you an example of the landscape that the data science underpins. We've all seen these kind of ads here, which are native ads, so they're disguised to look like articles, but what they do is they offer up more information and often link to kind of instead of being a hard sell like here, the Dell ad you can see on the right is saying a laptop, whereas these kind of these ads here are sponsored, but they offer up useful content first to try and bring the user in, and then we'll kind of enter into like a soft sell. So that's another type of format. They help publishers to monetize their exit traffic as well. So previously, if somebody was browsing a publisher and consumed the content, and it was in the end of their lunch break and they had to get back to work, they would quit the site, whatever. But these kind of ads allow publishers to monetize people leaving, because a lot of people will click through to leave the site, and it's an extra economy on top of normal. You've got your video ads, so you've got your pre-roll, in-page video, so outstream units that fold out between content. Like you've got your pre-roll on YouTube, skippable after 5 seconds, mid-roll, which you can't skip, a bit like TV ads, and video, obviously mobile video as well. You've got your audio ads, and remember all of these programmatic formats. So you've got your audio ads on Spotify, but also on SoundCloud as well, Google Podcasts and Apple Podcasts. All of those are providing an alternative to traditional radio advertising. and they are targetable again via the data that underpins the publisher that is selling that inventory. And soon now, out of home. So within the next few months, it will be possible for me sat at my desk to run an ad in Piccadilly Circus on one of those billboards, because these billboards are in high demand, and they're plugged into bits of technology which allow an open market to bid on those spots. I'll probably have to remortgage to get an ad spot there, but it will be possible. The infrastructure is built, and what you're finding now, and this is what I mentioned earlier, is that digital and traditional advertising are blurring. You've got your billboards there, which are technically out of home, ad units, but they're being served digitally, and now they're connected to the wider open web, which means people who, like me, who use bits of technology to interface with ad exchanges, which I'll go into in a second, means that I can bid on inventory such as that, which makes it a much kind of it realizes the real value of ad space, because in an auction environment, first price wins. So it means that publishers aren't over or under valuing their ad space, and that again is realized through real-time bidding, which is kind of real-time data science in action, where every single ad that's bought and sold is left as a record for that publisher, knowing what the last impression was sold for. It can then know whether it needs to increase or decrease its sell price based on demand. So you've got a real-time supply and demand environment going on, which is underpinned by the data that is surrounding it. So here's just a bit of information about the kind of scale we're looking at in terms of programmatic based inventory around the world. That's the number of impressions, so that's one single ad served. That's the number that these are the numbers of available ads that are around the world, accessible via the open web programmatically. Obviously USA has the highest there, the UK actually second, and so what I wanted to demonstrate here is the sheer number of transactions. So in the last 30 days, if you added all those numbers up, that's the amount of transactions that were bought and sold between publishers and advertisers on the open web programmatically.
Tom's audio.
That can sit
Sorry,
across.
Tom.
Yeah.
I just lost your audio there for a few seconds.
Oh, can you hear me now?
Yes, I can hear you now.
Yeah, so I was just saying that obviously this scale of inventory needs something to orchestrate it, because if you wanted to run a campaign in the USA and you're faced with 7 trillion potential ad impressions, your audience are in there somewhere, but you need to know how to find them, and this is where kind of the data science part is relevant. So I've touched upon this briefly, but the difference between data-driven real-time bidding and non-RTB is just simply targeting these points here, targeting demographical groups, behavioral groups, contextual-based environments, and inventory being priced in real time, allowing for a feedback loop and continued optimization. So, for example, an advertiser may put a bit of script, a bit of HTML on a order success page, and whenever a campaign bought or a user that is sent to that retailer site goes on to buys a pair of trainers, that script will fire and feed back to the platform and tell them that actually this conversion came from odds checker and was on this ad unit at this time on this device, and so on and so forth. So there's this feedback loop that's going round and round and round, where which equips the machine learning to start understanding where the engagement is, where the efficiencies are, and where the actual end KPI is. And in the online retailers case, that would be sales. So it would start to identify in clusters where the top publishers that are sending through, sales, but also where the highest engagement rates are through things like banner click-through rates and things like that. So the actual flow of this is somebody clicks to a web page, the publisher puts the ad impression up for auction, whether that's a video ad unit, or whether it's a native ad or audio, any of the formats mentioned before. The winning advertiser who bids the highest will win that ad spot. And then the ad is served, and the user will see that ad, and it's up to them whether they click it or not. So you can see that it's very important for algorithms and for products that are built to trade media, are listening to engagements or various different data signals that allow the algorithms to learn and to understand where the engagements are, and to customize themselves based on the behavior of the audiences of the advertisers themselves. And what's actually happening now is that kind of V1 of optimization models that kind of use the very basic level of data signals. It used to be that it was the case where there was one optimization model for all advertisers. And what we're seeing now is the uprising of companies who are purpose-built, and that their sole purpose is to build custom first-party algorithms for advertisers to plug into these buying platforms to allow that are tailor-made to whatever advertiser it is that they're partnered with, to kind of gain more efficiency online towards their advertising goals.
Tom, just
Yeah.
quickly, before I ask my question, in terms of questions, if anyone's got them, the chat area of Zoom you can use to pose any questions.
Yeah.
Actually, I've got one here from Andy Jagger. If the customer doesn't click on an ad, does that ad get penalised or shown less often?
Good question, and actually that's one of the signals that the algorithm uses. So every impression served will be re-evaluated by the algorithm model based on the first level of engagement, which is the click through. So it would what happens is there's a technique called bid shading, whereby for example, a publisher could have a very low click-through rate on its banners or its media or whatever format, but have a really high conversion rate. So it may sell loads of trainers, this publisher, but the click-through rate on the ad units are low. So what it has to do is it will either shade or adjust the bid, or how much it was willing to pay for that ad unit to make it commercially viable. So once the ad is bought, it's bought. So and the publisher gets paid. That's the end of that transaction. So the algorithm and the data science has to retrospectively adapt and evolve based on where the users are being found, because obviously it's great if you're putting up a bunch of millions of ads, but if no one's interacting with them, then it's the job of the algorithm to listen to that and to turn its attention towards inventory sources that have higher engagement. Having said that, there are other forms of measurement in this industry as well. So, for example, branding. Branding is a very different game to performance. I've worked in performance largely, mainly my entire 10 years, but branding is all about eyeballs on banners. So even if there are no clicks on banners, it depends what the top level KPI is, or measurement of success. Because for example, a successful branding campaign could be one that that generated minimal clicks, but actually had a high reach, and hit a very large amount of unique users. So it depends what the goal is of the algorithm, and it depends what the goal is of the strategies of the campaign. So that's something that is related to the first party algorithm conversation, because Nike, who want to do a huge branding push, they may not be interested in direct sales from a particular campaign, but they might be interested in stimulating awareness for a new line of shoes or whatever, and realizing that through then Google searches and seeing an increase in the amount of people who are searching and using it, programmatic as a broadcast medium. But then if they're running a performance-based campaign where it's all about the sale of the trainers, then the algorithm would be programmed to be optimizing towards the areas of highest engagement, such as clicks and things like that. Because obviously without the click, you can't get the users to the site to then go on and purchase. So does that answer your question? Yeah, I'll continue. Okay. Cool. So so I mean, this is just showing you how the ad exchange works. This is the bit of technology that I want to talk about next. That's what I use. That's why all the data science is centralized. So obviously you have your publishers, apps, websites, audio platforms like Spotify, podcasts, whatever. Anybody who sells any kind of online inventory will use a bit of technology called a sell-side platform. That will then plug into an ad exchange, and then people like me use equipment called demand-side platforms to then to transact with the sellers in order to buy ad inventory with alongside data. So yeah, that's just another different kind of representation of that. So I want to talk a bit. This will leads into the science part, but having an apex point of purchase, which a demand side platform is, and it resembles the financial markets. So you'll have a trade, MetaTrader or whatever. You have a piece of trading software which it plugs into all the stock exchanges around the world, allowing you to kind of to buy and sell commodities and currencies. It's the same kind of, it's the same kind of concept with this environment here. So advertising publishers have their currency, which is their ad space. They plug into their ad exchange, and then you have buyers like myself who use a demand side platform to then interface with those ad exchanges and buy the ad space. They centralize everything from reporting and insights to centralizing all inventory sources. So we're plugged into about 400 different exchanges, including Google. They are their own exchange. You've got Microsoft, Spotify. I mean, like I said, about 400 exchanges. But some are verticalized, so there's one called Gourmet Ads, which is an exchange based on food and lifestyle publishers, so they represent them. And there's lots of different types of exchanges, but they all plug into one platform, which is where the algorithm sits, and it can see and all of the inventory that is available from those exchanges goes into what's called a bid stream. And a bid stream is what the algorithm is looking at all the time, and it will then pick and choose the right impressions, the right ads, the right formats, the right users at the right time from that bid stream to fulfill its goal, its programmed purpose. this is what it looks like. That will let me know if there's any more questions, because obviously I can't see if there's any chat questions, but just let me know if anyone has any questions.
No other questions at the present time.
Cool. So this is what it looks like from the inside. So you have your line items, and each line item might contain a different strategy. For example, I might be targeting, if it was a trainer campaign for Nike, I might be targeting publishers with the keyword running shoes, or I might be targeting an audience here of fitness and health, or I might be targeting a white list of publishers that the client has asked to advertise across. And then you get your metrics, it's a bit all over the place, but things like click the CPM, or how much it costs to buy 1,000 ads. That's the bundled unit price, and the engagement rates and conversion rates and things like that. And you can access the different inventories, and you can kind of just see how it looks from the inside. It's not that different from a trading console in the financial space. And this is the bit of equipment which sits right at the top. So we've moved through this. I've highlighted technological integration with data, inventory, and other service providers, supports an open programmatic advertising ecosystem. And as I mentioned before, the latest addition to this is the companies now who are providing custom-built algorithms that plug into these platforms via an API. And they sit and they listen to the bid stream, and they optimize the campaign. So I'll skip that one. Before we move on to what kind of model, how the models work and how the algorithms work and how the data is used, I think it'd be a bit useful to go into kind of what kind of data there is. Like I mentioned before, there's the likes of Experian who segment, and obviously Mosaic and people like that. But there's companies, obviously market research businesses, that their job is to collect data and segment them, the audiences into targetable and actionable segments that are then pushed through to the demand side platform that I showed you before as targetable segments. So all these companies that are, and they collect data in many different ways, whether it's through online surveys or through canvassing and or just through voluntary data submission, things like that. Their job is to collect the data. They then activate it into a format which is targetable via browsers. So at the moment it's the cookie, but I don't know if many people here know about the third-party cookie. You might have heard that that's now in retirement. We've been given 2 years for the cookie to be replaced with a different type of tracking, but essentially these companies provide these kind of segments here, like real estate investors, world travelers, different salary groups, family types, things like that. There are no segments really that don't exist. It's quite broad range of segments. And these
Tom, we just there about cookies, and I know that's kind of being stopped because of sort of GDPR type issues. Yeah, and I think there's a company I worked for a few years ago called Switch down in Totton. I think they switched to using a pixel on a web page as the basis for collecting the data rather than a cookie. So there are ways around using these to collect.
Hello. Can people still hear me? There we go. I think I'm back.
I can hear you.
Yeah, we can just about hear you. I think it must be that the whole world's streaming Netflix at the moment. So
yeah,
could be.
Everyone's internet's melting down.
Sorry, you were saying, Darryl, about Switch.
Yes. So we had this issue a few years ago, and I worked at this other company called Switch Concepts, and they did programmatic advertising, and we switched from using cookies to just dropping a pixel onto a web page, for example, and that pixel could grab the data needed.
Yeah.
So it wasn't using cookie technology, just using a different approach.
Yeah.
So,
and interestingly, fingerprint tracking was something that was about to be the replacement for cookies, which is basically looking at things like your browser size, your pixels on your device. Think really kind of auxiliary information that it's not personal, but it's very unique in a combination that can identify a user. But then that's also been stamped out. So everyone's still waiting to see where it goes. But yeah. Pixels and kind of decorated links, they're called, where with lots of parameters and things like that, I think are going to be one of the main solutions. But all these companies that you see here are having to change the currency in which they are activating the data from cookies into something else. So it's a big challenge for them at the moment, because no one has come up with a solution yet. And the clock is ticking on the 2-year kind of retirement sunsetting phase, where Google's Chrome browser will block third-party cookies as standard. So it's an interesting time, but these are the guys who provide the audience segments, and that's how we are able to reach certain groups of users. And this data is also submitted to these guys by publishers. So publishers like the Mail Online or Bloomberg or Forbes, who have, are able to segment the data and the users in those groups, or different content categories of their sites, are able to bucket those users and then submit them to these guys and sell the audience to these guys, who can then make them available to advertisers to buy. So here's some examples of some segments. I think this is for a B2B example that I used, but you can target, undergraduates, retired people, people who work for PLCs, SMEs, C-suite, people who are unemployed. It's all very, and this is the number of, and you can see on the right hand side the number of unique users seen across 30 days in the UK. That's not that's cookies, so it doesn't necessarily represent the population, but it's available bids. So here's the data points. Can you all still hear me okay?
Yeah, we still hear you.
Great.
Yeah.
Right. So here, these are the very fibers of online advertising. Basically, these data points are what algorithms use as their fuel. So whenever you navigate the internet, whenever you use your apps, whenever you use your device, all of these are being collected via scripts on various sites. So my DSP, for example, I have scripts on my client sites, and the data. The data of the user's journey on the internet when they're not on my client site is also navigatable, because it's plugged into the bid stream of every publisher in the world, so it can see the journey of every user. So all these different types of data points are on every single ad that is served. Even if obviously if it's not clicked, then that ad click data point isn't collected. But if you view an article on coronavirus, obviously topical, and when the data that's passed back to the DSP about that impression that was won on that site, not that I'd be serving ads on any content that has coronavirus, because that's another conversation, but it picks up the kind of the prevalent keywords on that page, so that you're able to kind of aggregate users based on contextual environment. Interestingly, there are businesses that provide brand safety measures. So for the likes of coronavirus, no one really wants to be advertising on content that is written about tough conversations and tough topical times, and so there's businesses such as Pier 39 and Grapeshot, who they have crawlers that crawl the entire web, every page, every keyword on every page, and then create brand safety segments that you can exclude content across the web that contains certain keywords. So I would imagine that a lot of people are using that function to stay away from sensitive topics at the moment. And an interesting case of that is I'll go into later with when working with Amazon. But these are the kind of data points that are being collected, and they fuel the algorithms and how they work. So this is just a reminder of the hierarchy. The DSP sits at the top. You've got your algorithm here. And then you've got your app web inventory, then trades across all the different formats of inventory. So it's a very top-down view. You set your targeting goals here, and then the data is then modeled out. So this is basically decision. I don't know how many people know about decision tree optimization, but that's the fundamental kind of basis on which the models that I use at least are calculated. So it resembles that if this then that, and an or logic. So for example, if the sports page on Mail Online has produces a click-through rate of 0.2% at an efficiency of 20p per click, then bid this amount. And those depths can the depths at which these trees can go down is down to 1,000 different decisions and different variables and different adjustments and bid modifications based on the algorithm's learning. So you can see here that maybe the red dots resemble conversions of or desired actions. It could be sales of trainers. It could be people who watched a video for 30% all the way through, or it could be whatever KPI, whatever. It will gather the data that surrounds every one of those actions, and it will look at the common properties of those conversions, and then it will feed that back into the custom model that then is refreshed with updated bidding, updated kind of bid adjustments and tactics based on where the data itself is showing the highest relevance to the campaign's purpose. I mean, this is just a complete mind meld of a diagram, but it kind of shows the kind of flow of your commercial objective, your KPIs and targets, your conversion tracking here. So the feedback loop then goes into your optimization, which then results in your profitability or volume. Then you move into campaign structure improvement, which increases quality and click-through rates. And one thing that's important here is that data science and machine learning goes hand in hand with human intervention. It's nothing without human intervention, because without somebody setting the strategy and commercial objectives at the top, the machine learning itself would not it would not be able to find its way intelligently or humanely, because advertising is essentially one person communicating a message to another person. The means to which it gets there, machine learning or not, is where the technology lies in it. But the ultimate thing to remember is, again, it's human to human, but in this case, machine learning and data science is what sits in the middle, whereas for example, internal business data management, for trend analysis or of big data within internal businesses that's not used for marketing is a different story, because it's not essentially about communication or advertising. It's about understanding trends and efficiencies. So that's one difference that that data science is being applied to advertising than it would be to an internal use within a business, especially huge corporations with lots of data and making efficiencies within their processes. So yeah, so I don't know if anyone's seen these kinds of models before, but this one best fits the machine learning, the actual how it works for advertising. You've got your unsupervised learning, so visualization of data, compression, structure and discovery of new inventory. You've got your audience segmentation for under clustering, and then targeting, using that clustering to then target audiences and audiences that look like those audiences. You've got your supervised learning. Again, this is what I meant by human intervention. So setting certain parameters and prerequisites and key information that only a person would understand, and it needs to be input on in the first instance, but then can be once it's had that intervention and those parameters are in place, it can work within those confinements and produce predictions. That's things like weather forecasting and market forecasting and things like that. And then you've got reinforcement learning. So I think actually I'll go into these a bit more now. So yeah, unsupervised learning. So this could be highest click-through rate on ads. The model will see, okay, well these publishers here and these ad units here, and it would say, right, unsupervised would say, well, these are the areas of the highest click-through rate, and if that's the goal of the campaign, it would direct media spend to these areas, to these publishers and to these placements, and that's without any confined or any prerequisites or anything like that, because that's what it's been told. If we look at supervised learning, it's the same kind of thing, except there's predefined parameters, pre-qualified audiences, classification of certain metrics, elimination, inclusion. So for example, you've got all your dots here, but actually this could be an audience segment of people who are interested in trainers, but actually what we're trying to find is women's trainers, which could be the blue dots. But the algorithm, unless it's supervised, unless it's told that, unless that's predefined, it won't distinguish between the two. So it needs that distinction, and that's how the supervised learning works with. And actually, all of advertising is a combination of all three: supervised, unsupervised, and the reinforced. So here is an example of the reinforced, so for example, input apple, it's a mango. Wrong, it's an apple. Okay, cool. And next time it recognizes an apple, right? So that's it, as an example. Campaign for Amazon. The algorithm thought that targeting content with the word Amazon on it for an Amazon jobs campaign that was recruiting 200,000 pickers and packers to handle Christmas deliveries. It initially thought very quickly, target Amazon inventory because it has relevance to the brand. But actually, there's a massive Amazon rainforest, and also there's a ton of negative PR about Amazon. And actually, it's much better to exclude any content that targets Amazon from any campaign run for Amazon. But it needs that reinforced learning, and it needs that. Even though it's correct in its logic, it's incorrect in its application. And so that's again one of the three components the machine learning and how it ultimately helps the campaign to optimize. So and then eventually what you'll get is, over time, you'll get closer clusters, and and budget is spent less on grey dots, which is discovery, where it will cast the net wide to try and find properties that match these orange or blue users, and it will focus 80% of its daily budget on the areas that have consistent performance and consistent efficiencies, and use less budget to kind of explore inventory. But that said, a successful 80% of on target inventory is going to ebb and flow much as the market does. So today it might have an 80% efficiency rate, but there needs to be a percentage of budget that's always looking for new inventory that matches these the targets of the campaign and its previously learnt efficiencies, because you always have new entrants to the market bidding on the same inventory and the same audiences, and it's important that the algorithm is using its footprint and its look back to find new inventory, but it's a feedback cycle. So the more success it learns from, the better it can then find new inventory, and the better it can prospect for and grow a client's campaign. Yes, this is. I drew this blueprint for my last company to just show how it all fits together. I think this is actually my last slide. I don't know how long I've been going for. I hope it's not too short. But basically, essentially, I run what's called a trading desk, which is again, I sit across all the biddable platforms, and they all have their algorithms, and you buy media, and somebody's either going to go to the client site, they're either going to convert or hit the goal of the advertiser, and become a customer and go into their data management platform, or they're either going to visit the site and leave. And either way, they're collected by the data management platform, which can segment them into various different segments represented by the squares and the triangles, which but then allows the technology to do things like lookalike modeling. So it'll say, right, what's a square look like? What are the common properties of a square or a triangle? Let's look at the bid stream at all the impressions that are coming up available that have a 80%, 90% lookalike match to these users that have acted in certain ways on the site. That's then pushed back through to the platforms to allow us to target lookalike users, whilst that the feedback loop goes round and round and round and round and round until the algorithm itself is trained to listen to all of the various different properties of the users that are behaving in certain ways. And one of the interesting things is all these properties here can be extracted into visual studies of a client's customer. So we could say, actually, your most valuable customers are actually users who browse these publishers. They live in this postcode. They visit these websites. They browse publishers with these top keywords on. They spend this amount of time on your site, and they revisit this. They revisit this many times during the month, and they also overlap in these audience segments. They're also, Volvo owners, and they also there's a 40% chance that they are also they go to holiday in the Bahamas, things like that. So you can take these segments and all this data and then find out where there's overlaps across all the data exchanges to then either expand campaigns out or to understand more about audiences, which can then be used and transferred across different parts of a business. I think that's it. That's it for me. I hope I hope that wasn't too technical or not.
Oh, thanks, Tom. That was great.
Yes, thank you, Tom.
Yeah, I think well, I just, it was a difficult one for me to try and find the right position to come in to this presentation with, because obviously this is from an advertising point of view, and obviously that's my speciality, and obviously some things that I say are jargon, that and I know the meaning of, and but to some people it may not be an industry that's very well understood. But I hope what I've shown is that how data science and how the data footprint, especially that is collected via browsers and things like that, are used to train algorithms that are then used to then optimize media. That was loosely what I wanted to kind of go through.
Okay, that's great. Thank you,
Sweet.
Tom. If anyone's got any questions, I mean, so rather than on chat, if you want to just pitch in with any questions you've got or any thoughts or ideas.
I've got well, I've got loads of things buzzing around my head. One of the things is we talk about training models, Tom.
Yeah.
And so, are there, is there a model per advertiser? Is there a model per campaign, or do you just have one sort of super humongous model that works for everyone? Or so how do you sort of, at what sort of level do you kind of break up the models and say, okay, this is a new model with this set of data?
Yeah, good question. So when you license a bit of technology, like a demand side platform, it comes with its own built-in optimization software algorithm that is one size fits all, and that does its that works to a point, but for example, what I do, and actually it's one of the emerging things now, are businesses that are providing first party algorithms that can go down to strategy level. So for example, I have a gambling client where the campaign is split into two. One half the campaign is to find new customers, and the other half is to encourage existing customers to keep playing. And they have their own algorithm, because the KPIs and the goals of those two campaigns are very different, and the behaviors of those two audiences are very different, and the desired actions are very different. So it's a case of understand. Again, it goes back to the infographic of strategy at the top. Algorithms and data science really are bound by the strategy in which they're used for. So I used unique a different algorithm for every strategy, basically. So yeah.
Okay. Anybody else?
Good.
Yeah, I've actually got another one, Tom. That is that what people are, I now know a lot of people have said to me that they've been talking about something, and then they get adverts for it.
Yes.
And so they don't know, they haven't quite worked out whether it's their phone, is it Apple, is it their Facebook app, is it their Alexa in the room, but how much of that is going on?
Yeah. So that is they don't openly admit to doing that, but I know that. So for example, when you install Facebook and you have an Android phone and you hit accept all these permissions and all these things, one of the ones is your microphone. Obviously things like Alexa and Google and all these things have to be listening for when you say hey Google or hey Alexa or whatever, Alexa. They have to be listening in the first place, so they're collecting audio data about all the conversations, and that it's not that there is no public statement yet on that, but that is also what is being used to make first party audience segments by the likes of Facebook and Apple and Google, because they are taking audible interest and turning it into targetable segments. So yeah, it's true. It's happening.
Yeah, actually, can I jump in on that? Because I read a very interesting article where actually Amazon were essentially admitting that they're using, whether they're doing it live or not, but they're looking at additional trigger words within the recorded data, well, with additional trigger words for Alexa in order to well, they say to pick up on things like break-ins or people in distress and that kind of thing. But clearly, if they can pick out additional trigger words, they can use that for marketing as well, I would have thought.
Well, exactly. And the thing is, it has to be listening in the first place for it to hear the trigger. So it's one of those kind of it's one of those things where they would say, but hey, you enjoy the function of hey Google, but actually, if you don't want it to be listening, then you can't use that function. But actually, it's listening to everything, which is quite scary. But yeah, I mean, it's a conversation where you think, well, okay, publishers monetize their content. Publishers are free. A lot of them are free. Some are behind paywalls, but the majority of content online is free because of advertising. And if it can be more relevant, a single dude who's at university doesn't want to see nappy adverts. It's a balancing act of privacy and relevancy, and I think that's what's happening at the moment. It's an evolutionary stage, but it is quite impactful when you do see an ad after you've saying, "Oh, I just had a conversation about that, and I saw it pop up on my Facebook feed." Well, it's happening, but it could actually be quite relevant as well. But it's whether or not the privacy is on point,
So it'll be interesting to see, with the likes of GDPR killing the cookie, whether that will also go to the extent of killing audio triggered devices.
Well,
and does these things, are they going to survive legislation?
Yeah, the thing is they haven't officially. They have nothing to regulate because they haven't been enough in. I don't think investigations or complaints or whatever. I think people are still skeptical as to whether it's a coincidence or not. But it's definitely something that needs to be addressed because if you visit, as soon as you visit any website, you have to click accept on the consent bar to allow your data to be consumed by that publisher and then shared. So but there's no permission with Alexa or the Home Hub thing from Google initially. I think that might be something that's introduced, or it might even be there and people just you know what people are like with terms and conditions. I know what I'm like. It's to accept because I want my shiny new Alexa to work, but you might be accepting something that you're not reading. I don't know. I haven't, but they certainly haven't. There isn't certainly anything official yet. But I can see
it's got another question here.
Yeah.
from Annie.
Annie, yeah.
Who says thanks, very informative. So is there a time frame? Or unless Annie, do you want to jump in with your question?
I'll just go ahead and answer.
Okay, yeah. I don't know if you quite understand the question, but if you can to answer it,
Yeah, absolutely, makes total sense. So basically, the algorithm that I use, it has a 21-day look back. So it's a campaign will technically require a certain volume of activity in what's called a learning phase. So this is where it's listening to every click, every further action on a website. So when you tag up a retail site, for example, there will be different conversion beacons that run from view product, view category, add to basket, payment page, abandoned basket, and payment complete, and all these it's called the conversion funnel, and all these data points are matched back to the source of that user. So the algorithm enters a learning phase whereby after about 7 days, usually. It's quicker sometimes if it's higher spend and the engagements are there, but it'll have a learn phase, then it'll have an optimized phase. But the look back window is 21 days, because obviously as much as people's behavior change, and interestingly, all the algorithms have dramatically changed over the last few days because of coronavirus, because the number of people who are at home, more people are online, which means there's more ad impressions available, which means the price goes down, which means the algorithms are bidding less and winning more, and performance is going up for some of the campaigns that aren't affected, and the algorithms need to be able to adapt to that in real time. So what the 21-day look back is for is to spot is to look at the average run rate, and then to be able to benchmark that against anomalies and understand whether or not those anomalies are temporary or whether they're permanent, and if there's a consecutive 3 days of a certain property that is or data point that is prominent, it will then start factoring that in, into its understanding of its audience and how the audience has changed. So like I said, interesting at the moment, everybody's at home and on their devices.
So is now a good time to start an advertising campaign?
Well, interestingly, it depends, because, for example, a couple of my clients are events businesses. They've changed all their events to being online with the same ticket price. The algorithm has to adapt to finding people who are more open to running event or participating in online events rather than booking offline events, things like that. But inventory is certainly cheaper at the moment because there's more of it, and it's it's quite remarkable, actually. Yeah.
Okay, interesting.
Cool.
Another question, actually, Tom, Andy again. Doing some experiments with Google Ads a few months ago, a colleague and I were looking at how, we were in an area which was the bid cost was quite high for some of the key phrases we needed. So we did an experiment of actually setting our bid price below, not trying to kind of match that, but setting it below. And we saw something quite interesting, is that our ads wouldn't run at first, because during the beginning of the day, we found that we didn't get any ad impressions, because I guess everybody was outbidding us. But it seemed like as the day went on, we then started to get some traffic. And I was wondering whether that was what I kind of call budget exhaustion, whether other people's budgets were getting burnt away, and that was bringing the bid price down. Is that a possibility, or are we just imagining things?
No. It could be. It's very much a part of that will be bid exhaustion, but also it's the amount of competition. So and also time zones. So for example, one of the most expensive keywords on Google is it's in gambling. You can pay anywhere up to 70 quid a click for play casino online. That, for example. It's obscene costs. But if you're targeting the UK with just a UK-based campaign, but you have a huge brand that operates in the UK and Canada and other areas, there's time zone differences, which means that budgets will exhaust at certain times, which means that the average price will go down. There's also quality score metrics as well. So if your quality score is higher than somebody who's willing to pay more, but their quality score and ad relevancy is lower, which is all determined by data science and the relevancy of the crawled landing page against the ad copy against the keyword, then even though you're bidding less, you will win the click, or you win the impression, at least at a higher position, because a lot of big companies just chuck as much money as they can at it and try and outbid everybody, but actually if you had a higher quality score and relevancy score, that's Google's kind of internal quality assurance to make sure that users who are searching are met with ads that are as relevant as they can be.
Yes, yes.
Yeah.
Oh, that's very useful. Thank you.
That's okay.
Okay. I'm just going to post in chat a link to our LinkedIn group, because we have a group on LinkedIn if anyone wants to join that, so we can all sort of stay connected. Obviously, we'll be putting stuff on the Meetup site as well, and Andrew is kind of recorded it, so we've got a record. So, I mean, we're scheduled to run till 8:30, but happy to close it early unless anyone's got any other questions, comments, or ideas that may have been sparked by what we've heard and discussed today.
Great to have you along to listen to that amazing webinar. Look forward to the next presentation in April. All right, bye for now.